Right, so we've got some things going on here. I've got the area. I know I'm going to be using the area formula, but first I think not a bad idea to make a little sketch of what we've got going on. So we've got AB, and that's 10 centimeters. And then we've got AC being a length of 5 centimeters and the triangle being overall 15. So I don't know, it's going to be half that length, isn't it? It could look something like this. Now it says there's two possible answers, and that is because if that's 5 centimeters there, it is possible that there would be another one coming off over there. And yeah, so there's more than one way that this could happen. But what we're going to do first of all is say, right, BAC is that angle there, isn't it? And the area of a triangle is a half AB sin C, although in this case it would be sin A, wouldn't it? And we have the B and the C there. What's important is that your two lengths are either side of the angle you've got there, and the area we've been told is 15. And the A and the B we know are 5 and 10. So if I put that in, that is 5 times 10 is 50 over 2, or half of 50. Sin C is 15, so that means 25 sin C, doesn't it? So sin C, or sin, I should be putting theta in there really, shouldn't I? Sin theta will be 15 over 25, and 15 over 25 actually is 3/5, isn't it? So that's my sin theta, but they're talking about cos theta. Well, this comes about thinking about our trig identities, and we know the daddy of the trig identities is that sin squared theta plus cos squared theta equals 1, and we're going to use that here to say that therefore I know that cos squared theta is 1 take sine squared theta. Now if sine theta is 3/5, sine squared theta will be 3/5 squared, which is 3 3s are 9 over 5 5s are 25. So cos squared theta is going to be 1 take 9 over 25, which is 16/25. But we want the two possible values of cos theta, so what we do is find the square root of both sides, and cos theta will therefore be, well, the positive and negative square root of 16 over 25. You can use your calculator, but you don't need to, because the root of 16 is 4, the root of 25 is 5, so it's going to be plus or minus 4/5. And then, given that BC is the longest side, we need to find the exact length of BC. Now, if it's the longest side, that means that actually this must be an obtuse angle. So we're looking at something like that. So it's not just, if I do cos theta of so theta is cos to the negative 1 of 4/5, I get 36.869 degrees. If I were to do cos theta of negative 4/5, I get 143.13 degrees, which I could have reasoned a different way, because that number there is 180. Take that one. And the reason that happens is, if I was to do sketch a bit of the cosine curve like that. 4/5 would be like at 0.8 would be about there, and negative 4/5 or negative 0.8 would be there. So if that comes in there and that comes in there, the distance between there and 0, that's 180 degrees there, is the same as that distance there. So that's how that happens. Anyway, we need that angle because we need the length of here, although we don't need to use it as that, do we? We can use it as cos. Sorry about that. Let me stop blithering on. We want the length of BC, so we are going to be using c squared equals a squared plus b squared take 2ab cos c. Now we know that cos c, because we want the obtuse angle, is the negative 4/5 one, that we're going to be putting it into here. Now I want the exact length, so I'm going to be going for the square root of a squared, which is one of those two lengths, doesn't matter which one, 5 squared plus 10 squared, take 2 times 5 times 10, and then cos theta being negative 4/5 times negative 4/5, and that's going to give me, I can put it all in my calculator like that, square root 5 squared plus 10 squared take 2 times 5 times 10 times negative 4 over 5 equals the square root of 205. And that is the exact length. When it says that, they do not want you to give it as a decimal and round it.